Hi everyone, today we're going to talk about frame allocation. So the main question that I want to cover today is just how many frames should be allocated to each process. So last time we talked about page replacement and we talked about demand paging. So one question that we should ask is, so should each process be allotted the same number of frames? Should they be able to pull from the whole set of free frames, or should they be limited to a certain subset? So that's the main question to ask today, to answer hopefully. So first, let's consider a single user, single process system. So let's say that we have 128 kilobytes of memory. So this is main memory. And let's further say that, okay, I don't know, say 35 kilobytes is used up by the OS. So no processes can put anything in memory there because it's being used by the OS. So if our, and this is assuming a frame size of 1 kilobyte. Okay, so this leaves, what was it, 93 free frames. Okay, so now if that single user creates a process, so say they spawn a process, now that process, and it's also going to be divided into pages, can put its pages anywhere, right? So wherever it finds a free frame, it can just go ahead and use it up. Right? So this is perfectly fine when you have a single user, single process, but you're not going to have that. So the question becomes, what happens when either we have a single user but we have multiple processes? So say we have another process here that needs to schedule in some of its time, and we have another process here that needs to put its pages into memory, and so on and so forth. At some point we're going to have that overallocation issue we talked about last time, and there's just not going to be enough frames left. There's going to be no frames in the free frame list, and so now we have to do page replacement, and we saw some of the issues with page replacement. We could have a lot of page faults. It could slow down our system. So one way of controlling for this, and ultimately controlling for the number of page faults that we might have, is to use different kinds of frame allocations. So two things are really going to be our main constraints. The first of the constraints is that we want to define a minimum number of frames, and this is going to be that each process will get, and this is going to be defined by the instruction architecture. So the instructions in a given hardware architecture are going to have different minimum frames that they need. So they're going to have some instructions that are going to require to span across multiple pages, or well, so on and so forth. But so that's going to be defined by the actual architecture. And then we're going to have a maximum number of frames, which is just going to be the number of frames in our physical memory. So that is a lot of wiggle room, a lot of wiggle room. But those are really the only two constraints we really have, and so we really need to figure out a smart way of allocating these pages, these frames, such that we can, optimize our experience. Okay, so the first algorithm for allocation is equal allocation. So now I have these processes, and I have so each one of these processes has some amount of pages maybe. But that's not really the point here. The point here is that I have 100 free frames, and I'm going to equally divide these frames among the processes. So each one of the processes, so I've already blocked out my OS, but I have 100 more free. I don't know, let's go with purple. So I'm going to divide this, okay, so my evenly is not going to be So great. And I know I don't have 10 here, or 5. I only needed 5 people. So that means that each one of these processes are going to get 20 frames allocated to them. So 1, 2, 3, 4. So, this is going to go to this one, this is going to go to that one, so on and so forth. And when each one of these processes needs to schedule in a frame, it's just going to use the spots that are allotted to it. So the blue is going to come here, yellow is going to be to schedule in here, and anytime that maybe we want to do a page replacement, although this is not 100, you don't have to do this, but you could reduce it to this local scope where it would just replace space from its own pages. But we'll talk about that next time. So this is equal allocation. So we equally divide it among the processes. So it seems fair, seems great, but should we really do this? Is it reasonable? So let's imagine that this first process here, so process blue, only has 10 frames. So it's a really small program. It only has, 10 pages, only needs 10 frames ever. In its whole existence, it's only ever going to need 10 frames. So again, when we have these 100 frames that are free, if we're going to allocate equally, then this is going to have 20 frames allocated to it, and it's only ever going to need 10. So the issue there, we don't necessarily need to allocate that much space to it. So instead, what we can decide to do is we can do proportional allocation. And so for proportional allocation, we're going to take the process virtual address size. So that means in the virtual address space, how many of the addresses are coming from that process. Divide it by the total virtual address space. So I'm just assuming I have these 5 processes and nothing else. Of course, that's not the case, but so I'm going to divide it by that and then multiply it by the total frame. So I'm going to get this proportional allocation. So for instance here, if the total here is 300, so that's my total virtual address space, this space only needs 10 pages, and I'm going to just do it based on pages instead of kilobytes or anything like that. Then I'm going to multiply that by the total frames I have, and I'll get about 3. So this process in blue here, its portion will just be 3 frames here in memory. Okay, so it'll have 3 frames, and so now we have this demand paging system where maybe we only need to load in the 2 frames at the beginning to get it up and going, and then it can kind of switch between the frames that it needs, or the pages that it needs, to order to do its whole execution. So that's the idea behind proportional allocation. Some issues. So when you have any increase in multi-programming, meaning that you have more programs in there, this is automatically going to drop the number of frames in this, especially in the proportional allocation it will, and in the equal allocation. So if you have more processes, you're going to divide that open space up between more programs. So you're going to always drop in the number of frames. The other issue is that this does not account at all for priority. So if you have a process that you have a higher priority, you may want to allocate more frames to that higher priority process. So neither of these kind of take into account that. So as a programmer, you might want to take into account that priority too. Have some sort of override that if it has a higher priority, then it may get a bump in allocation. And that can be easily taken into account here in this equation. So this would be what it would normally get, and let's say that this one this one had a priority of 1, and the rest of these have lower priority of 10, 11, 10, 9. So this one, even though it only is supposed to get 3 pages, it has a higher priority. So you could add some factor, I'll call it alpha, and alpha will be based on priority. So you can easily get around that. You can add it into that equation, and proportional allocation now becomes priority based as well. The last issue is this global versus local versus global replacement, and I kind of hinted towards this at the beginning. So the idea here is that there's two different types of page replacement, and then we talked about just general page replacement in the page replacement video. And I didn't really talk about the difference between the two because it doesn't really matter unless you're thinking of it in the sense of frame allocation. So here, if in local, so this is main memory, I'm just going to say MM. If this is one process, this is what it's allotted, so this is process 1, is what all it's allotted. In local replacement, if I need to page out something, or if I need to page in something, I have to choose from the space that was allotted to me. So I can only replace pages from my own process space. In global page replacement, this is where you can get into trouble with frame allocation, because if you're doing global replacement, potentially you could replace pages from other processes. So global replacement is looking at the whole space. So no longer are we just looking at the space for our process. We're looking at the whole space, and we're going to look and see, based on our page replacement algorithm, we're going to look and see which page we should replace in the whole main memory. So now what that can do is that can make it so certain processes have more pages allocated to it than it was initialized with, and therefore then there's other processes that are going to be losing frames. And this leads to a very serious problem called thrashing, and that is what we will talk about next time. So let me know if you have any questions, and thank you.